An aluminum cylinder with a constant volume, oh, did they say constant? I think so, of 27 pi cubic centimeters is being shaped by rolling it into the desired proportions. You ever take Play-Doh and you make a snake and you do like this? The quantity of the Play-Doh, let me rephrase that, the volume of the Play-Doh doesn't change. We're assuming the density remains the same as well. And the radius gets smaller, the length, we'll call it the height, is going to get wider. It's that sort of situation, okay? So let's keep writing. Let's use purple. What color do you want to use? Purple? Okay, good. Aluminum cylinder with a constant volume. I'm just going to go ahead and write dV dt equals 0. And volume is 27 pi cubic centimeters. Now, if you're thinking, well, if the volume is constant, why do I need the volume? You never know. I'm going to write it down anyway. Is being shaped by rolling it into the desired proportions. As it is being rolled, the height is increasing. Okay, so it's going to be a positive number, and it is 0.2 centimeters per second. At what rate is the radius changing? When the height is 5.2 centimeters. Okay, can we go for the obvious here? We don't know the radius, but that's okay. We'll get there. Let's switch colors. I'm going to come over here. I'm leaving a gap because of what I don't know. But if you want to go ahead and find it, you can. Volume is, all right, cylinder here, pi r squared. That would be the base. That would be the circular part. Times the height. If you need a visual for it, there we go. There's a circle and there we go. And so this is your height. And this itty bitty distance right here, that would be your radius. Okay. Let's keep working. I'm going to find the derivative of that. It's going to involve the product rule. So can't avoid the product rule this time. We do not have a relationship between the radius and the height like we did in a lot of other problems. So dV dt equals f prime. So pi r squared. Let's get a little crazy on this. We're going to call this one f and we're going to call that one g. Okay, just good to know. So f prime g plus f g prime. Okay, let's start plugging in what we know, and then you'll realize we truly don't know the radius, but that's okay. So dV dt is 0 equals 2 times pi times radius. Stop, find it. Let's just go ahead and stop and find it. This is why we needed to know the height, we needed to know the volume so we can actually find the radius. So the volume, again, is pi r squared times height, and the volume is 27 pi equals pi times the radius squared times the height, and the height is 5.2. And we're going to use this to find the radius. So let's grab a calculator, and we'll store it as r once we get it, unless it's a decimal that truncates. So we would divide by pi, they would cancel on both sides, and we'll have 27 divided by 5.2, and that gives us, well, that's gross. And then we'll take the square root of that last answer that we got. And so we did 27 divided by 5.2, take the square root of that, and I have 2.279. So we now know the radius. We will store it as r, so 2.279. Now, if you wanted to, and I'm going to do that this time, if you wanted to, instead of writing 2.279, I'm going to put r. Because I can. Because I want to. Because I'm cool like that. We don't know the rate of change of the radius, and we do know the height. We have a lot of things that are out of order in this situation. We have this constant at the end. It should go in the front, but I'm writing it in the order that you see it. Plus pi times the radius squared. I'm going to be consistent. You don't have to do this, but I'm going to make it green. My radius is green, doggone it. And dH dt is 0.2. Okay? We're going to solve. Let's do it. Let's do it. Now, there's actually some stuff you could do. Like if this was super cruel and was calculator inactive, there are some things, well, they wouldn't do that to you with these kinds of numbers. But there are some things you could do, and let me tell you what they are. Both of these terms have a pi in them. Both of these terms have an r in it, and we do know what r is now, of course. So we could actually divide by r and by pi, and it would cancel the pi, the r, the pi, and one of those r's. And it would simplify our life a little bit, but let's not. So let's instead keep going with this, and we're going to clean up this term, and we're going to clean up this term, and we're going to take this term and move it to the other side. So we have r. Did I store it as r? I don't recall. No, I didn't. Okay, we'll take that. We'll store it as r. There it is. All right. Pi times my radius squared times 0.2, and that is 0.326. We're going to bring it to the other side. So negative 0.326 is equal to, okay, 2 times pi times my radius, there it is, times 5.2, and it is 74.450 times dr dt. Okay. Something feels very wrong about this. Give me just a second. Something looks wrong. I'm sorry to waste your time with this. Oh, it is wrong. It is wrong. Okay, this number is wrong. And I'm going to fix it really quickly. And here's what happened. I didn't do 0.2, I did 0.02. So actually, it's just a matter of moving the decimal one place. So this is going to be 3.26, whatever. And so I'm going to fix it here. I apologize. I'm not going to start the video over. I think it's a good little lesson to be careful. So I don't feel like starting the video over. So it's going to be 3.262. There we go. That's better. That's better. And I'm actually going to fix it here. There we go. So I'll have those actual numbers. So final answer is dr dt, which would be this divided by that. So it is negative 3.262. We'll just go up and press enter. There we go. Instead of storing it, you could do that. Divided by 74,450. We'll go up and get that one. And we press enter. And we have negative 0.044 watt. We're measuring the radius with respect to time. The radius is measured in centimeters. Time is measured in seconds. Centimeters per second at that particular instant.